When we register multiple implementations of a service type using the AND methods, we saw that a service descriptor for each registration is included in the service collection. This demo will explain why the container allows multiple registered implementations, given that we've already seen that it only resolves the final one. We'll look at a use case for registering multiple implementations of an interface or service type by applying a rule pattern in our application. We'll use this technique to support adding functionality to the tennis booking application with minimal changes to existing code. In the tennis booking application, members can make court bookings. Before the booking is completed, the booking should be evaluated to ensure that it complies with any rules that exist for bookings. The rule processing takes place inside the booking rule processor. Its constructor accepts an IEnumerable of iCourt booking rule, an abstraction defining behavior that rules must implement. When the dependency injection container resolves services for this class, it will attempt to resolve all instances of the iCourt booking rule service type and inject them as an enumerable collection. Note that the container will only resolve multiple instances when the parameter is typed as IEnumerable of t. It does not resolve multiple implementations if you specify an array or any other collection types as the type for the parameter. In those cases, specifying them as parameters would cause an invalid operation exception to be thrown at runtime. The passes all rules async method iterates through all the injected rules, evaluating the court booking against each of them. If we add a breakpoint inside the constructor, we can observe the injected rules. I'll start debugging the application, and once the site loads, attempt to make a booking for one of the available courts. The breakpoint is hit because the container creates an instance of the booking rule processor. The enumerable of rules is empty at this stage because we've not registered any yet. This behavior is significant. The application functions normally even though we have no implementations of the iCourt booking rule service type registered. If we continue debugging, the booking will eventually be accepted. We're going to register several rules with the dependency injection container. Before we do, let's review their dependencies. Inside the rules folder, there are several rule implementations. The club is open rule will check that a booking is made during the opening hours of the tennis club. It implements the iCourt booking rule interface. The other four rules are similar and have various dependencies. You're free to explore their implementation in your own time. I've gone ahead and reviewed the dependencies required by each rule. The club is open rule, max booking length rule, and max peak time booking length rule all depend on some configuration defined in the club configuration and booking configuration classes. The members booking must not overlap rule and member court bookings max hours per day rule both depend on the scoped iCourt booking service. We'll head back to the program file to begin adding our registrations. We know we'll need 2 additional configuration classes for these rules to function, so let's start by registering both of those in the way that we've done previously. Each will bind their values from the relevant section of the configuration for the application. We can now register our rule implementations. Each will register the same service type, the iCourt booking rule. We'll have to use the add methods here, not try add, because we want all implementations to exist in the container. The first 3 services only require configuration, and because they access it via the iOptions service, they can be registered using the singleton lifetime. The final 2 services depend on a scoped service, so they must also be registered as scoped. It's okay to use registrations with different lifetimes here, as long as they're appropriate for the registered implementation type. We can debug the application to check the effect of these new registrations. When the breakpoint is hit inside the rule processor, the injected IEnumerable of iCourt booking rule now contains 5 rules. Each of these can now be evaluated in turn, checking that the booking meets the conditions of all rules. If we continue to make a booking for the early hours, we now receive an error stating that the booking cannot be completed as it would violate one of our rules. Using this approach, it would be very easy to add new rules to the application. We'd first create a new implementation of the iCourt booking rule interface. We'd then register it with the iService collection, and that's it. At runtime, the new rule would be injected into the booking rule processor, with no changes required to the rule processor class itself. This is a perfect example of the benefits of applying separation of concerns and the single responsibility principle, which contribute to ensuring the application is easier to maintain over time. If you'd like to experiment with this yourself, why not try adding a new rule to the application that ensures bookings are only accepted if they're made for a date and time in the future. As a hint, you may want to depend on the IUTC time service in your new rule. I'll include an example of a possible implementation in the final after solution in the exercise files. In the last clip, we looked at a use case for registering multiple implementations of an interface. There is an issue with the current approach that I want to highlight. What happens if the same implementation is accidentally registered twice? First, we'll test what happens when we duplicate registrations. Then we'll look at an alternative, safer registration technique using the try-add-enumerable method. As part of the booking service, we can improve the user experience by ensuring that only valid times are selectable when a user makes a court booking. This feature is implemented similarly to the booking rules, with an unavailability provider interface defined in the project. We can see that this is a fairly simple interface, defining two overloads for a getHourlyUnavailability async method. The booking service accepts an enumerable of these in its constructor. We can add a breakpoint here in the booking service constructor to witness a potential risk when we test it in a moment. Several implementations of the unavailability provider interface exist in the project. I'll paste in some registrations for these services. You may have already spotted a problem, but let's debug it to see it more clearly. The breakpoint is hit after the book court page starts loading, and we receive an enumerable of unavailability providers. However, the first two of these are for the same implementation type, the club closed unavailability provider, which has been included twice. Returning to the registrations in the program file, indeed, the pasted code contains an error and repeats one of the registrations. This occurs because the add methods are not idempotent and therefore will allow the same implementation for an interface to be registered multiple times. For this particular provider, it's not a significant problem for it to be executed twice. However, the situation could easily be more dangerous if the duplicated service had side effects. Therefore, when registering multiple implementations for an interface, it's recommended that we prefer the try-add-enumerable method. This method prevents duplicate registrations of the same implementation type. Calling the try-add-enumerable method is another example of where we need to work directly with service descriptors. We can provide a single service descriptor, as I'm showing here. There's a convenient overload of the try-add-enumerable method that accepts an IEnumerable of service descriptor, which I prefer using in this scenario. This provides a slightly terser syntax for registering multiple implementations. We'll create an array of service descriptors, and I'll paste in 5 descriptors to register the providers. Importantly, this pasted code still includes an error with a repeated registration for the club closed unavailability provider. Let's run the application and check the resolved providers. We have only 4 resolved providers when the breakpoint is hit, and there's no duplication. We can let the execution continue here, and when we visit the book court page, this time the unavailable booking slots are much more identifiable. Much like the other try-add methods, using try-add-enumerable is recommended to avoid unintended duplication and to express our intent more clearly when we register services.